All right, algebra, this is lesson 1.4, solving absolute value equations. So we have some vocab words. Absolute value equation. Somebody tell me what that is, Chloe.
An equation that contains an absolute value expression.
Very good. And extraneous solution. That's a fun word. Go ahead, Nico.
An apparent solution that must be rejected because it does not satisfy the original equation.
So when you see the word extraneous, think extra. That's how I remember it. It's outside of the box. It doesn't fit in the answer. That's what helps me remember that one. Okay, so when you're solving an absolute value equation, do you guys kind of remember what an absolute value is? Go ahead.
It's like the value of a number.
That's a good way to say that, value of a number. The biggest thing that you need to remember is it kind of gets rid of the negative sign. It can read inside of it with a negative, but when you find the solution to it, you wouldn't have the negative on the solution. You need to write down these properties of absolute values in your journal. I'll give you a minute to do that. I'll go over them, though, while you're doing that. So for an absolute value of A, that has to be greater than or equal to 0. Which makes sense because the absolute value gets rid of the negative. For number 2, if I have a negative absolute value, I really just have the absolute value of whatever that number is. I really just have that as the whole number or a fraction. If I have A times B inside an absolute value, you could separate it and have the absolute value of A times the absolute value of B, and you would get the same answer. And the last one, if I have a division problem in the absolute value, I could separate those and take the absolute value of A and divide it by the absolute value of B, and you would still get the same answer as long as B doesn't equal 0. All right, let's put some numbers in here so it makes a little more sense because the letters get confusing.
Example 1?
Yep, example 1. So we're going to solve each equation. And then graph the solutions. And when it says graph, currently right now we're dealing with just a number line, not like the whole X and Y value graphs, just the number line graph. So first we need to solve for A. We need to write 2 related linear equations. Why is there 2 possible answers? What do you think? Wild guess. Yep, go ahead.
Because whenever I look analyze, isn't the answer to the opposite?
Yes, you could have both the opposite answers. So you could have the positive version or the negative version, but the absolute value makes them positive. So yes, so you have to write it in 2 formats when you're solving this. So you have to solve it as if your answer is positive 6, and then you also have to write it as if your answer is negative 6, since it has absolute value. So now you have 2 equations that we have to solve. So we're going to move what? To get x by itself. Yeah, we're going to add 4. So 6 plus 4 is
10.
10. And then negative 6 plus 4 is negative 2. So then you have 2 potential solutions for this absolute value equation. X could either equal 10 or x could either equal negative 2. Now let's look at that so you kind of understand it. If I were to plug a 10 up here, 10 minus 4 is what? 6, right? So that makes sense. If I were to plug in a negative 2 right here, negative 2 minus 4 is negative 6. But then I have the absolute value lines, so that's what makes it a positive 6. So you see how the 2 answers can go back into the x and it makes sense? Because otherwise you're like, why am I doing 2 equations? So, all right, so let's do B. Oh, wait, we got to graph it. And on your graph, I don't need you to write all of these 4, 0, 2. I just put the 0 on your graph, put the negative 2, and the 10. Like, that's all I care about. So when you're labeling it, I just need the -2, the 0, and the 10, because those are the 0 shows me where the middle of the graph is. The -2 and the 10 are your two answers. All right, so now let's look at B. So the absolute value of 3x plus 1 it says equals -5. Can we have a negative answer for an absolute value? No. So this would be a, what's that weird fancy word you wrote for your vocab? Extraneous. Right, because you can't have a negative as an answer for an absolute value equation. So you just say no solution. You don't even have to solve anything. So if you wrote it down in your journal, maybe circle that negative number on that -5 and say can't have a negative answer. And then no solution. So that way you remember why. Does that make sense?
Yes, ma'am.
The other two algebra students, does that make sense?
Yes.
Do we also have to graph the no solution?
Nope. There's nothing to graph. It can't be on the graph.
So, wait, what?
So because this has a -5 here, see this -5? You can't have, when you have absolute values over here, you can't have a negative answer. Because that absolute value takes away the negative, remember? So then you just say, I can't solve this, no solution. Excellent. So go do monitoring progress 1 through 3. Take your absolute value of 4x minus 10 equals the positive version of 2 times 3x plus 1. And they're just trying to mess you up because they have this 2 on the outside of the absolute value. Okay, so they're trying to throw you. Okay, so just write it as a positive. Or, and then our second equation, we still write 4x minus 10. Remember, we have to apply the negative, but the negative is only applying to everything in this absolute value. So you see here, they wrote the 2 first, and then they wrote the negative to apply to everything. If you were to distribute that negative, it would be -3x minus 1, correct? That's the point. That's what you, right? We're adding that negative in there.
Yes.
As remember, we're doing a positive version of the equations and a negative version of the equations. So we have 2 versions we're solving. So let's just solve this left side first. First thing we should do is what? Distribute. Yep, right here. 2 times 3
6x.
and 2 times 1.
2x.
Excellent. Now combine like terms. So we're going to move, do you want to move the 4 or the 6? Oh, well, they wanted to move the 6. I would have moved the 4. So minus 6x, what's 4 minus 6? -2x. Now let's move the 10. How do we move the 10?
Plus 10.
Correct. Which would be?
12.
And then our last step?
-2. Divide 12 by -2.
Correct.
Which is -6.
Excellent.
So x plus 6.
So there's one answer.
Yes, 4x minus 10 to the bracket
Open bracket. Mm-hmm.
plus 1. And then the bracket. The bracket is when you have to do second, right?
Right. We do the innermost parenthesis first.
Parentheses first, bracket second.
Correct. Yeah, even if you wrote parenthesis there instead of a bracket, it would still work. You just have to remember you do the innermost parenthesis first. All right, you ready for this half? All right, so the first thing I'm going to do is distribute this negative. Negative times 3 is just -3, and negative times 1 is just -1. Now I'm going to distribute the 2. So 2 times -3 and 2 times -1.
So -6x.
Yep, minus 2. Sweet. Looks a little simple. Now we can combine like terms. So I'm going to move the 6x. 6 plus 4 is 10. Now we're going to move the 10. So plus 10 gives me 8. And then divide by 10
8 divided by 10.
is 0.8. Now, I would also accept the fraction 8 over 10 reduced, which would be 2 over 5.
0.8.
Yep. You can do either the decimal or the fraction. I don't care.
Then we gotta add all the answers.
No, that's it. You have two solutions. X could equal -6. All right, ADD over here. Come on, man. Or X equals 0.8.
Yeah. That's it. So we just had to solve.
You just have to solve. The biggest thing is making sure you set it up correctly at the beginning with that negative that you have to throw in there. That's it.
Next example.
All right.
I didn't put so much space into this one.
Now we're going to go ahead and do the last example.
Oh,
I think this is the last one.
that's the last. Oh, that's the last one.
So let's go to this last example. Come on, recording. X. All right, so the first thing we check, is this a negative number over here?
No.
No, so we can attempt to solve this. So we're going to write our two equations, dropping the absolute value. So the first equation, we leave it all positive. 2x plus 12 equals 4x. The second equation, we have to put the negative after the equal.
Yep.
So 2x plus 12 equals -4x. Yep. All right, so let's solve the left side first. What do you want to move?
12.
Move the x's together first. So minus 2x. What's 4x minus 2x?
2x.
Very good. And then get the x by itself. We divide by 2. So 12 divided by 2.
So x equals 6.
Excellent. So we have one answer. Now on the right hand side, let's move the 2x. So subtract 2x. -4 minus 2.
-6.
It's -6. And then divide by -6.
-2. X equals -2.
So we have two solutions. So this one wants you, because we have this negative, it wants you to check to see if I plug those in, are these extraneous solutions. If I plug the 6 in, 2 times 6 is 12. 12 plus 12 is 24. On this side, 4 times 6 is 24. Can 24 equal 24?
Yeah.
So that one would be correct. So now let's plug in the -2. -2 times 2 is? -4 plus 12 is?
8.
8. 4 times -2 is? Can 8 equal -8?
No.
No. So then this would be an extraneous answer because of that negative. So the key here is if I know I have a variable on the outside of the absolute value, see how this has the x in the answer here? And I came out with a negative answer, a lot of times that's going to be an extraneous answer. So then you just would not include that. You reject that, x equals -2. You just cross it out and say no. So the only solution would be x equals 6.
I get it. You plug in the 6 with the x.
Right. So just keep an eye out. If you get an answer over here that's a negative, and then you have the variable up in the equals section, check it. Because most of the time it's not going to work out. Now, let me throw this at you. If this was a -4x, like originally, would it potentially work?
Yeah.
Because a negative times a negative is a positive. So it could potentially work if that 4 was originally a negative. It may not still, but it could. All right, any questions about that? That's kind of an odd, extraneous, fun word. You guys have a new vocab word now. All right, one more example. One more, example 6. Yeah, this one had a lot. But it doesn't have that many problems, so you have like 3 more to do when you go back, and that's it. All right, so we're going to solve this. X plus 5 absolute value and absolute value of x plus 11. So we're going to create our two tracks, the positive version and the negative version. So I have on the left x plus 5 equals x plus 11. Oh, they're just going to do the negative version to start with. Probably to see if there's an extraneous solution. All right, so let's do the negative version first. So distribute the negative, what do you get?
-x.
Minus 11. All right, so then if I move the x, I get what? 2x. You can move this one plus, so I get 2x. And then I can move the 5. So negative 11 minus 5.
Negative 60.
Oh, already this answer is going to be negative, isn't it?
Yep.
Divide by 2 and I get a negative 8. Okay, so now the positive version. X plus 5 equals x plus 11. So again, I get 2x. Oh, they moved the 5 first. Oh, they subtracted the x.
Yeah, minus x.
Yep, you're right. Subtract the x. So x minus x is gone.
So there's no x.
And then 0 equals 6, which does not work. So and 1, so this is already a false statement. So the positive version doesn't work. And the second version, x equals negative 8. Remember to check it because it could be extraneous. So
You just plug it in.
we plug it back in. So I'm going to go back over here and look at it. So if I plug in negative 8 up here, what's negative 8 plus 5?
Negative 3.
Which then it would be absolute value of that, so it would be 3. And what's negative 8 plus 11?
Negative 8 plus 11 is
3. So does 3 equal 3?
Yeah.
So in this case, the negative answer is correct. So this is why you check it. All right, any questions? That was kind of a lot. I tried not to go too fast. I know I can go fast sometimes. All right, so your assignment is to finish through number 13, and then you're done. So that's what, maybe 4 or 5 problems you have left to do? Ish.
Class ends at 10.
At 9. So you have 6 minutes. But this is not due till tomorrow, and you know I'm not going to grade it till Monday.